In this lecture, of course, I will make you to easily understand enzyme specificity as well as the lock and key model or lock and key hypothesis. And at the end of this particular lecture, I'll give to you some questions so that you can test your knowledge based on what we have discussed. So let's look at enzyme specificity and what it actually means as well as lock and key hypothesis. I'll also be using daily life examples, and I will share some of the examples with you in this particular lecture to make you easily understand exactly what I'm talking about. So let's begin. So when we hear the term enzyme specificity, we simply means that a specific enzyme will only bind, that is, to a particular substrate for reaction to take place. This is about specificity, that is, a particular substrate must bind to a particular enzyme for reaction to take place. And these vary. This specificity is about the shape of the substrate fitting to the active site of the enzyme, and reaction is going to take place. So let's look at some daily life example for enzyme specificity. And beginning with an example, I'm going to use this mobile telephone as an example. This mobile telephone we refer to as enzyme. Why is it enzyme? Because it has an active site. The active site is this particular hole, which you can see here, for the substrate to plug here. So the substrate of this particular enzyme, which is referred as the telephone, the substrate is going to be the charging, that is the charging cable. So that cable, which is going to plug into this hole for this phone to charge, is going to be the substrate. So the cable itself is a substrate, and this telephone is the enzyme. Why is this an enzyme? Because, of course, enzyme contain the active site. Let's assume that the active site of this telephone is these plugs, which you can see here. Assuming I'm going to come now with a cable to fit it into this telephone, and it is going to start charging. Now, this is the head of the cable, which of course I'm going to feed it in to this particular active site. Let's assume this is the active site of the enzyme itself, and this is the substrate. So this substrate will come to bind to this active site, and once it fits in, now of course it is going to start charging. You can see it is charging. The telephone is now charging. You can see that is the charge. Now it is the same like when the enzyme or when the substrate come to bind to the active site of the enzyme, a reaction is going to take place. Assuming that this telephone is the enzyme having the active site, which is this particular area for the substrate to fit. Once it fits, what will happen is charging will begin. This is an example, the same example, just as an enzyme which is specific for a particular substrate will bind to that active site for reaction to take place. Let's look at another daily example. Of course, I'm assuming this pen. Of course, you can see this pen have a cork, and this is the pen itself. And now this is the enzyme. Why is it an enzyme? Because this one have an active site, a particular area where this pen is going to fit. Therefore, we assume that this particular cork is the enzyme itself containing the active site. If it contains the active site, then this particular pen is going to be the substrate. In other words, this substrate must need to come to bind here to the active site of this enzyme for the reaction to take place. And it must fit, for specificity, a particular substrate. It means that this substrate must be particularly for it to fit to this active site of this particular enzyme. Now I'm bringing this pen to fit here. It has to enter here, and once it enters, you can see it is the same as the lock and key model. In other words, a particular substrate must bind to a particular active site of an enzyme for reaction to take place. This is enzyme specificity being explained. Now I'm going to use another example. This is the mouse of the laptop, and looking at this mouse, it has an end, which this end has to fit to the plug or to the port of a computer, which in this case it is going to be a laptop. Of course, this particular head here, which you can see, is the substrate. It means that this will go to fit to the active site of the laptop or the PC or the computer. The computer serves as an enzyme. Why? Because it has the active site, that is the area where this part will fit to that area for it to work. Therefore, this one here is a substrate, and that port which we have to insert this substrate to it is the active site of the enzyme, which in this case, the laptop is the enzyme. Now I'll go to plug this head, and you're going to see a light will display here. This light is just like the reaction which will occur. if we didn't plug this thing, of course, there will be no reaction. But reaction will only occur when I plug this thing. It is the same. There will be no reaction when the substrate do not bind to the active site of the enzyme. Reaction will only occur when substrate bind to the specific site of an enzyme, the reaction will occur. Let me plug this cable now, and you're going to see the light here. And also, not only the light are you going to see, you're also going to hear a sound. Let's do it. You have heard the sound, and this is the light. You can see the light here is the red light. As you can see, the light is red. As you can see here, it is the same. Without this particular light, this light is assuming that the reaction, for example, is taking place. Why? Because we have inserted the substrate to the active site of the enzyme, which in this case, the active site of that enzyme is the laptop port, which we are going to insert the head of this cable. It is the same. This is enzyme specificity. Now, let's look at example in the case of digestion. We want to look at the digestive enzyme known as lactase. Of course, lactase is an enzyme which we digest, or it will actually break down lactose, which is like milk. If the active site of lactase, which is the enzyme, actually meets the substrate, or let's assume that the substrate in this case is the milk, whenever the substrate is found and come to bind to the active site of lactase, lactase will break it down. You see, this is an example. So lactose is the substrate and lactase is the enzyme. Look at this. The enzyme called lactase have an active site, and the lactose, which is the milk sugar, anytime milk sugar is found or milk and move to the level where it combined to the active site of lactase, a reaction is going to occur. This reaction is actually the breakdown of the lactose by the lactase. This is an example of enzyme specificity. In other words, anytime that milk combines with lactase, it is going to break down the lactose, which is the milk. But if we replace the lactase with amylase, in other words, instead of the lactase to break down the lactose, now we replace the lactase with amylase. You're going to notice that even though amylase is an enzyme, anytime lactose is found, no reaction will occur. Because of course, the enzyme amylase is not specific for lactose. So lactose is only specific for the enzyme lactase. So I believe you are getting the point. In the case where it is instead amylase which is found, because lactose is not specific for it to bind to amylase to cause reaction to occur, then no reaction will occur. This is enzyme specificity. But if we replace back the amylase and insert back the lactase, reaction will occur. Why? Because the lactose is specific to react only with lactase, because it's going to break it down. But if at all the amylase was found, instead of the lactose, starch was instead present, the amylase will break down the starch, because starch is specific for amylase. In other words, amylase will only break down starch, but amylase is not going to break down lactose, which is sugar. So therefore, when we talk about enzyme specificity, it means that only a specific enzyme will bind to a specific substrate for reaction to take place. If the enzyme or the substrate is not specific for the enzyme, no reaction will take place. But if reaction at all occur, then it will be very slow. Therefore, in other words, enzyme specificity simply means that a particular substrate must bind to a particular enzyme for reaction to take place. Just as I've quoted, only the enzyme lactase will break down lactose, and the enzyme amylase will break down starch. But if lactase is found, but instead of lactose being found, we instead replace the lactose with starch, no reaction will take place because starch is not specific for lactase. But on the other hand, amylase is specific for starch. If starch is present, then amylase will break down the starch. But if starch is not present, but amylase is present, no reaction will take place. This is enzyme specificity. A particular enzyme will only act to a particular substrate once it binds to the active site. Now at this level, I'm going to ask some questions so that we are answering these questions together. And to those of you who want to follow all the various questions we have set up for this particular lecture, then you want to make sure to follow the link below and go ahead to answer the series of 10 questions we have prepared for this particular lecture. We have 10 of them, and we are going to ask just a few here. Then the remaining part of it, you want to make sure to go to our community tab and participate to these particular questions and answers for you to make your own choices. It's an MCQ questions. Go there and make sure that you participate so that you're going to better understand this topic better. So let's look at the first question. What do you understand by the meaning enzyme specificity? A. Enzyme work on any molecule. B. Enzyme work only on one particular substrate. C. Enzyme slows down reaction. D. Enzyme change its shape constantly. Which of these is correct? So you want to make sure to go ahead to reply to the correct answer in the comment section. Let's look at question 2. So for you to reply in the comment, you're going to say 1, you put A, B, or C, or D. Choose one of them. That is 1 / you put the answer. 2 / you put the answer. Then 3, 4, 5, 6, 7, 8, 9, and 10 of the questions will be set in the community tab. Follow the link below this video. Go there and participate and answer some of the questions. So let's look at question number 2. Which analogy best describe the lock and key model? Number 1, a hammer hitting a nail. Number 2, a USB plug fitting into a pot. Number 3, a blender mixing ingredients. 4, a flashlight turning on. Which of these are correct? Go in the comment section and tell us. Write number 2 / you put the correct answer. If it is A, put 2 / A. If it is B, 2 / B. If it is C, 2 / C. And if it's D, 2 / D. The remaining part of it, that is from question 3 to question 10, will be set up in the community tab. Follow the link below, go to the community tab section, answer the various questions to keep yourself in check and test your knowledge on this particular lecture. See you again in the next upload. You want to make sure to go ahead to like, comment, and subscribe, and also enable the notification bell icon so that anytime we publish a new video based on this topic and other related topics, you want to get notified so that you are going to follow the lecture as well as participate to some of the community quizzes which we are going to set to keep yourself checked and up to date. Enable the notification bell icon to receive new post notifications anytime we post a new video. See you again in the next upload, and bye-bye for now.